Hey Sammy, I was just going to make this quick video here just before I get into my meeting, but your question was asking you don't know or understand the idea of limits. Essentially, limits didn't really apply until this section. This is the main part that you'll need to understand, but let's just guide you through what's happening here. Okay, so if we ignore the limit of a approach infinity for now, okay, and we just focus on anti-diffing this with respect to y, okay? So what they did was they anti-diffed the function e to the power of negative y, which we know is k over the negative value there, so hence why they had negative k e negative y. And when you integrate, remember, because this is a definite integral, it's between 0 and a, so they got 0 and a over here. And then to work it out, we know that through fundamental theorem of calculus, this means you will substitute a into where y is, and so you've got negative k e to the negative a is what you're seeing there. And then from there, they subtract, so minus, and you're substituting 0 into that. And because it's negative, double negatives become positive, and that's k e to the power of negative 0, which is really 0. That's how they got this next line. Okay, so this line here came from simply integrating this and then substituting a and 0 in. Okay, so that's where we're up to right now. Okay, so we understand that when they substituted a and 0 in, this is what you get, right? The next part is to understand, well, they're asking now, we don't know what a is, but they're saying, what if I find the limit for both functions, because you've got two terms here, or two functions, and they're interested in, well, if the limit of a, so meaning if a approaches infinity for both functions, what would it equate to? So what they did here is essentially they wrote out the limit of this and the limit of this. So if I write it out separately, I'm finding what if a approaches infinity for the first function? The first function was negative k times e to the power of negative a. And then the other one was, what is the limit? Or if you forget about the word limit, if you just say, what happens if a approaches infinity? Okay, so if a becomes a really large number for the second function, which is k times e to the power of 0. In both scenarios, you can see already, well, the first thing you would say is, well, this doesn't have an a. So when you say if a gets really large, what happens? Well, it doesn't really affect it. It doesn't change things. It's still going to be k times e to the power of 0 is 1. That's why it ends up being k. That's why they had k here, so plus k, because that's not affected by a. So this function here has no relevance to a, whereas this one does. This one, on the other hand, has a relevance to a. So they're asking, well, if a approaches infinity, meaning it becomes a really large value, this a value here becomes really large. So then what does this entire graph tend towards? Is there a value that it gets to? That's what you're thinking about. So my encouragement is then to understand what this may look like graphically. See, I don't know what the graph is because I don't know what k is, but I see that there's a negative. So that tells me that this is an exponential graph, which normally looks like this, but a negative implies that it goes like this. And then notice that there's also a negative value on a there. So a negative value on a would imply that it looks like this. Okay, so that's my rough understanding of what this graph looks like. Now what you can see is that if a is the x-axis, because that's essentially it's with respect to a there, and this is the function of y, then you can see that as I increase a, as a approaches infinity, can you see that the graph started off very large infinitely, and as I increase a, it gets smaller and smaller and smaller. I can already say that as a reaches closer to infinity, then the graph is approaching 0. True? The graph is getting smaller and smaller. So that's why they're saying over here, well, if the limit of the function that affects the a, okay, and you can actually ignore the k if you want to. I'm just drawing it overall for you to see. But all they wrote there is they're only interested in, and I'm just going to roll all this out so it doesn't confuse you. They're only interested in this part, because this is essentially saying negative k times e to the negative a. Does that make sense? negative a. So really, it's only this function that I'm interested in what happens to a if a gets really large. That's what that line is trying to say there. But they wrote it in a nice way where they're just simply saying negative k is a constant, limit of a approach infinity. It really just means, what if a becomes infinitely large? What happens to this function? What does it tend to? Now, based on our drawing just now, or you can even just sketch this graph here, e to negative a should be a graph that goes like this. It means that if a approaches infinity, so if a gets larger and larger, we can see that the graph gets smaller and smaller and smaller, which approaches 0. So that's why I can say, well, if it approaches 0, it's not 0, but it's infinitely small. So infinitely small, or close to 0. So that means whatever negative k is, I'm multiplying to a number that is so close to 0, we know that that just makes it very small. Negative k times something like 1 over a million, or 1 billion, we know that that value will get really, really small. So if it gets really, really small, let's think about it. A very small number, close to 0, plus with k, because that's the next part, right? So we know that this gets very small, and you multiply to a number, it gets it overall very small, and then you're plussing k. What is that overall answer approximately? Well, a very small number added on to k means like there's an insignificant or a very insufficient added value to it, because it's just like k plus a very, 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 very small number, and you might as well say it's approximately k. So that's why in this particular line here, they've simplified this entire line and said this will approximately be a very small number, which let's say call 0, or imagine 0. It's not 0, but imagine 0, and you're adding that on to k. Well, then the overall result will be approximately k is equal to 1. So when you ask what is the limit, I think of the word limit as, just to let you know, we're going to focus on a hypothetical. And in this case is, what if a is really large? Because it has an arrow that points towards infinity.